Hello, everyone. Hopefully you're doing well. We're going to complete these sections. This chapter, of course, functions and graphs, with these sections covering distance and midpoints. We could have a very long discussions about the importance of distance and midpoints formulas, circles, especially, because it's always very good to know your way around a circle. So clocks or angles, maps, and compass are based on circles. So circles occur everywhere in nature, in ripples on water, patterns on a butterfly's wings, and cross-section of trees. Some consider the circles to be the most pleasing of all shapes because circles are like everywhere. So the rectangular coordinate system gives us a unique way of knowing a circle. It's enable us to translate a circle geometric definition into an algebraic equation. So to do this, we must first develop a formula for the distance between 2 points, okay, in a rectangular coordinates. So one thing we do before we go over the definitions, if I can move this a little bit, let's see if I can move it. Nope. You know what? I'm gonna keep it that way just to explain. All right, suppose, on a rectangular coordinates XY, okay, if I have a xy as a rectangular coordinate, and for 2 points, and because now I don't know what are the real numbers representing each coordinate, I'm gonna call them x1, y1, and the second point I'm calling it x2, y2. Know that those are just real numbers. Both of them are real numbers. For now, I don't know what are they. But my first point, suppose my first point, if I have a first point, like give me, you know, x, I don't know, I'll guess. Okay, my x1 falls right here. And my y1, that's a supposition, fall right here. So this is my first point. This point right here, we can say is x1, y1. That's my first point. And the second point, probably, let's suppose it's x2 here. When I plug it in the functions, it gives me y2 here. So when I put these two together, it's right there, okay? So my goal now, I want to find this distance. I mean, to take this one as a straight line. If I want to find this distance, I call it capital D or small d, this distance. It's not that easy that I just can count, because if I know the numbers remember, some numbers I already know. I know what is this distance, all right? And I also know what is this distance. So what I can do is really create a certain Pythagorean, a triangle with a right angle. So because it gives me right angles, for me, you see, having this point where I have x1, going through x2, and create that distance. It is a a right triangle that's I can use. Sorry, I can use Pythagorean theorem to find the distance between these 2 points. The 2 points, the distance that we need to find is represented by D. And, so notice that the distance between the 2 points on the, like I do it, we can use Pythagorean theorem. So let's say for us, remember, there should be another x2 here. So for me, that distance right here represents x2 minus x1. So that would be the distance. And that distance right here would represent y2 minus y1. So remember, remember how the Pythagorean theorem works. It says in a right triangle for an angle theta right there, if you have A down here, B here, and C here, C is the hypotenuse. The square of the hypotenuse is equal to the sum of the square of the other two sides, right? So this is the Pythagorean theorem. So for me, if I'm looking for D here, D square would be x2 minus x1 square plus y2 minus y1 square. Now, because I only need D, that's why we take the square roots of it. That's why we would take the square roots of x2 minus x1 square plus y2 minus y1 square. So that's where we get the definitions. We said the distance between 2 points in a rectangular coordinate. To compute the distance between 2 points, find the square of the difference between this x coordinate plus the square of the difference between the y coordinate. The principal square root of the sum is the distance. So that's, I know I speak a lot in order to show you this very quick, but let's illustrate it with an example. Define the distance between these 2 points and express the answer in simplified radical form and then round to 2 decimal. So we can, we should have decimal at the end. So when using the distance formula, it does not matter which point you call x1, y1 or x2, y2. So here also, we know the distance, if I call this one x1, y1, x2, y2, and the formula says it is x2 minus x1. Don't forget to raise it to power 2. y2 minus y1. Don't forget to raise it to power 2. Now, we have those numbers. x2 for me is 3 minus x1 is negative 1, all power 2, plus y2. No. I mistake there. That's not x2. x2 is 2. Okay. We're going to have x2 is 2 minus negative 1 square plus y2 is 3 minus negative 3 square. Okay. And we take the square roots of it. So the first one would be give us 2 plus 1 square plus 3 plus 3 square. All right. So that gives us the distance would be square roots of 3 square plus 6 square. So that would give us 9 plus 36. Okay. Sometimes it gives us something. So we can simplify it. We know that would be 45. And 45 is a 9 times 5. So we can have square roots of, 3 square root of 5. Or please do it in your calculator because they ask you for 2 decimal point. In your calculator, it will give you 6.71. So the distance can be square root of 45, or you can say it's 3 root 5, or you can say it's 6.71. That, of course, it all depends on how you are asked to provide the final answer. Okay, that's very important to verify that. Okay, if you're okay with that, then we can just continue. Midpoint. If I take the same examples here, when for the midpoints, remember, if you have a graph of I would go it like this. So let's suppose x1 give you a y1. This is the point, and x2 give you a, I'm gonna put it y2. Remember, your goal when you have these 2 points, that means right there you have x1, y1, and this one we have x2, y2, right? So this is the distance you're usually looking for by using the formula. Now the midpoint for us, I'm gonna call the midpoint capital M, okay? So if the whole thing here is the distance, right? D for distance, that you already know how to find the formula. Now you can look for the median on the distance. So the points as well exact that split the distance 50-50, you know. Is that for us half-half? So we call this point right here the median, the midpoint. So consider, because the midpoint is very important, that's why I said you need to review and verify it. So the distance formula can be used to derive a formula for finding the midpoint of a line segment between two given points. So you see that's the formula. Consider a line segment whose endpoints x1, y1, and x2, y2. The coordinates of the segment's midpoint is x2, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So to find the midpoint, take the average of the two x coordinates and the average of the two y's coordinates. So that's at some point what we doing there, okay? We're planning on doing. Let's suppose we have these examples. Find the midpoint. They could ask you also to find the distance for these 2 points. So we know midpoint that I would call M, you know, it's x1 plus x2 over 2, y1 plus y2 over 2. So what is x1? 1 plus 7 over 2. 2 plus negative 3 over 2. So that gives you 8 over 2 and negative 1 over 2. So we can still simplify. So midpoint for us would be 4, negative 1/2. So that would be the point that would fall exactly in the middle of, you know, the distance. Okay, so that's an example on how to find the coordinate of the midpoint. We average the x coordinates and the y coordinates. That's it. You know, remember it's a point. It's not a just one number like you do for the distance, right? The distance is, as you can see, it's one number, but the midpoint is a point. Like you have two coordinates. There is a comma between these 2 points, 2 coordinates. The circle, our goal is really to translate this circle geometric definition into an equation. So we begin with these definitions. Let's do it. A circle is the set of all points in a plane that equidistant from a fixed point called the center. So in order to graph a circle, what makes a circle like this? Suppose this is a circle, then this one or that one. What makes each of these circles different is the radius or the diameter. So we can say is the radius from the center. So the radius, you know, is come from the center, or you can say a diameter that's come from one side to the other, going to the center, to the origin. So a graph, you would always need, in order to graph construct a circle, you need to know the center and the radius. So every time they ask you to construct a circle, you need to have 2 numbers for 2 coordinates for the center to see in which quadrant around the unit, so the x coordinate you're located, and the radius are. So that's it. Okay, you need to know these 2 informations. But the good news is that there is a formula that we can use for that. The standard form of the equation of a circle with center HK, I call it XY, but remember this one can be X and this one can be Y. So the center HK and radius r, this is the formula for it. So once you know that, for example, if you have x minus 2 square plus y plus 3 square equal 4, what is the center? For us, if I rewrite this one in a different way, you will see x minus 2 square plus y minus negative 3. That's why we said positive 3 equal 2 power to 4 is 2 power to. So we end up having the center be 2 negative 3 and the radius is 2 because 4 is 2 power 2. Now, if they ask you to graph this circle, the first thing to do is to verify the center. Center, when x is 1, 2, y is negative 1, negative 2, and negative 3. This is the center of the graph. What is the radius? Remember, the radius must be only 2, so we would assume this is the radius. So we can graph like, okay, that's, it's fall in the 4th quadrant. I'm not going to only graph, simply graph for fun. I need to know what is the center and the radius and where exactly it falls, okay? So that's important when you graph something. Now, standard form of the equation of a circle. This is one. Write the standard form of the equation of the circle. Remember, using the center, we said the center is HK and radius R, and it must be x minus h square plus y minus k square equal r square. Now, if I'm looking at what you said, I would say h is 0, k is negative 6, so I can say x minus 0 square. All right? For me, that's what it's supposed to be. X minus 0 square plus y minus negative 6 square equal r square. R is 10 square. So what would you say is x minus 0 is just simply x square plus y plus 6, because 2 negative give you positive, square equal 100, right? So this is the standard form of the equation of a circle. So we can, the standard form of the equation of the circle is x squared plus y plus 6 square equal 100. And I believe we do as much as we can on this one. You can also use, if the circle is given, you can identify the radius and remember this is x minus h square plus x minus k square equal r square. So if I see x minus negative 3, that's why we're going to have positive 3, right? We're going to say power 2 plus y minus 1, the negative there, I leave it. What 2 ways to power 2 to obtain 4? Yes, 2 power 2. So at this point, you will say h is negative 3 and k is 1 and r is 2. So center negative 3, 1, and radius is 2. Okay, so what we need to do, we're gonna graph negative 1, negative 2, negative 3, 1. This is the center. And if the radius is 2, all we need to do with a compass, after we take the measurements, we know the 2 would be here. Okay. I know that's not the perfect circle, but you know what? I know the radius is supposed to be 2. So make sure you follow and see in which quadrant this one would be located. That's very important to verify that, okay? If you don't have any questions for that, we're gonna see the general form because everything we see so far is the standard form. How about the general form of the equation of a circle? It's a big one, yes. The general form is a big one, but the good news is like you learned in the previous chapter about how to solve quadratic equations. So if you plan on solving quadratic equations, then you should know how to deal with the general form of the equation of a circle. So all you need to do, combine all x's together and all y's and the constant term by itself. So I'm gonna just go over one simple example for you on how to write in standard form. First of all, I'm going to combine the x squared with the x and leave a space, and the y squared with the y and leave a space, and I'll add one to both sides, so the one would be on the other side. So I get rid of the constant. So add the constant to both sides, right? If you don't see what I'm doing, or because I skip some steps for you, I can even I'm gonna just put this one. Okay, let me put it there. Okay, for you, okay, for you, what I'm gonna do, I'm not sure I have enough space for that. What I said, I add one to both sides. That's what I did. That's why I have x squared plus 4x plus y squared minus 4y equal 1. Now I combine this. Completing the square. If you remember the technique of completing the square. Completing the square said take the coefficient of x, that means you said b minus b over 2a. No, take half of b, sorry, that's the vertex. Half of b and raise it to power 2 and add it to both sides. So I take half of b over 2 power 2 and raise it to power. So on the first one right there, b is 4 over 2 power 2. Those 2 power 2 is 4. So I'm gonna add 4 here, but I must also add 4 to the other side. And I will do the same for y. I see negative 4 over 2 square give me negative 2 square, give me 4. I'm gonna add 4 to both sides for this. Okay, that's important. That's very important. Now we can simplify. If you remember the completing the square, we simplify on the right side, so that would be simply 9. Okay, now what we do here, you can a plus b power. Remember, what is the square root of x? Square is x. What is the square root of 4 is 2, and the symbols in the middle. So x plus 2 is the one. When you simplify, when you extend, that will give you x squared plus 4x plus 4, and the other one will simply give you x minus 2. So you end up having the center negative 2, 2, and the radius 3 for that one. They ask you to write it in standard form. That's what you did. Do not hesitate if you feel like you're dealing with some hard time with that. All right, remember center here is negative 2, 2, and radius is the square root of 9, which is 3. All right, so you let me know if you have any questions, either for graphing these functions that appear to be okay because we have negative 1, negative 2, and we have 1 and 2. The center is here. So we would say the 9 is, you know, maybe something. All right, so I just show you, I give you an idea, not like graphing a real circle for you, but We're gonna come back to do more algebra, but in the meantime, just enjoy this chapter, functions and graphs, and you do not hesitate to contact me for any questions. Take care.